That's a theoretical question, okay? Don't do that diet. Okay, let's have a look. Okay, some say 20, some only want to drink 1 glass. Some say 20 glasses, some say 500. All right, why don't I give you the solution for this? It's got to be C, isn't it right? Yeah. That would be an incredible diet, okay? You would die pretty fast, actually. That's not the word diet, what the word diet means, okay? Okay, all right. So you have 200 grams. That was 200 milliliters. At 25 degrees of delta T, the specific heat per gram was 1 calorie per gram per Celsius. So that's 5,000 small calories, okay? 5,000 small calories. So if you have, that's 5,000 large calories, okay, because you have to divide it by 1,000. But your daily intake is 2,500. So you divide this by these 5 calories, so you would have to drink 500 glasses of water. Of course, you would die if you drink more than 4 or 5 liters of water because you deprive your body of all the electrolytes. All right, that's the first thing. There was some reference to this here that people were trying to drink as much water as they can, and they died. You don't drink more than 2 liters a day. Okay. The next thing is, of course, you would also lose a lot of weight because if you drink 500 glasses of water, you would go back and forth to the bathroom all the time. So that would be also that's not a great diet, but you get a lot of exercise. Okay, so it's 500. All right. So now let's talk about metabolism a little bit. And as I mentioned already. Yes, that's true. That's true. One second, I need to concentrate. Okay, so but the suggestion was implicit. So if you eat your food cold, okay, and forget about this 10 to the third, you actually, the difference between the big calorie and the small calorie, you actually would lose weight, okay, but that's not true, of course. But you would, if you eat your food cold, you would burn more calories than when you eat it warm, okay? That is true, but it wouldn't make a whole lot of difference, though. So this is what I mentioned. We use these carbohydrates here, and we breathe in oxygen, out comes CO2 and water, all right, among other things. And so the sugar contains 4,000 calories per gram. And this contains 9 calories, or 9,000 small calories per gram. A pound is 454 grams, okay? If you multiply this with 454, you get about 4,000 large calories per pound of fat. And here you would get, what did I say? You get 4.5, you get half of it about, yeah? So of course, more efficient is to store your excess energy in terms of fat. So can you imagine if our body would be designed to be stored in terms of sugar? You have these sugar rings around it and you double the size. You know, that would be absolutely incredible. So but in fat already, that's the most efficient storage. And if you eat more than 2,500 calories per day, you will store it in fat, okay? And I can tell about that for myself, okay? So now let's look at calories of these. We have these delicious Snicker bites. It says here, serving size, 4 pieces. Of course, there's the deception starts here. 4 pieces, serving size 4 pieces. Serving per container about 10. So that's 40 pieces actually in here, okay? And so these 4 pieces are 170 calories, the big C. That's why they write it the big C calories. So let's say it's 4 pieces, just for the heck of it, 50 calories per Snicker bite, okay? So they are delicious. And you want like some here? Oh, I'm sorry. You like some? Okay, you wake up, okay. All right, let's see. If I don't want to kill anybody. Yes, okay, okay. Okay. All right, 2 more and then we got to start working here, okay? Okay, good. So now, let's come back to this. We have the Snicker bite diet, okay? So you eat about 50 of those a day. That's a 1 1/4 pack of this. So you have your daily requirement of fat and calories, but not necessarily of nutrition. That would be great. So that would 50 a day maintains you at 100 watt, okay? And then your donuts, they have 400 calories. So that's 8 times as much. So all you need to do, eat only 6 donuts. You buy a dozen, okay? You have 2 days, okay? A little stale the next day, but you have 2 days, and that's at 100 watt. I don't recommend these kind of diets, though, but would be possible. The donut diet. Some people live on pizza diet. I don't have the caloric value for pizza here. It depends on what kind of pizza it is. Probably if it's Zachary's, it's much more than others, because they're about this 8 high, you know? So now you see this here, this is glucose, it has quite a high energy content. If you burn this, it's minus 1,074 kilojoules per mole. You know, if you compare this with aluminum, it's minus 1,676 kilojoules per mole if you make the oxide. All right, so that's the enthalpy of formation. And so now we have this, we go 100 watts, 2 kilometers if we walk slowly. And I'm asking you how many Snicker bites are required to fuel a 1 kilometer very leisurely walk. So would it be 1 or 10 or 100 or 500 or why don't you think about this? I hope I didn't hurt you with the Snicker bite. Got admitted to the hospital by the ambulance, and what happened to you? Oh, I got hit by a Snicker bite, okay? Okay. Where was the person? Yeah. There comes the lawsuit. Injured by professor. So that should be not so difficult. When you know 2 kilometers per hour is 100 watts. So now you need to see how many joules. You can calculate, how many calories one Snicker bite has. You know how many joules these are? Okay, so let's be safe. Let's take the middle. All right, I think I explained this to you, okay? That's a fun lecture today, at least for me. 50 calories, that's what we agreed, that's 1 Snicker bite, yeah? 50 calories, huge calories. It's 50 times 4 to get it into joules, it's 200 joules, but this is the big C, okay? So this is 1,000 calories times 10 to the 3. It's 200 times 10 to the 3 calories. And then 1 kilometer at 2 kilometers per hour is half an hour, isn't it right? So that's 1,800 seconds. 1,800 seconds. 100 watts times 1,800 seconds is in fact 180 times 10 to the 3 joules. You can calculate that. What times the seconds gives you the joules. And this is 200, and this is about 200. With this, the answer was 1 bite is about, you have to walk about half an hour slowly to burn 100 watt, that means you go to the Clark Kerr campus and you have walked it off one little Snicker bite. Okay? So I'm going to walk by there today, and so I need a Snicker bite. If I have some reason to walk by the Clark Kerr campus. You can actually walk somewhere else to walk it off, but never mind. But the professor said I should walk by the Clark Kerr campus. So that's one Snicker bite you would need to see. These are pretty powerful little morsels, aren't they? And so, never talk with your mouth full. So who is hungry and who's strong? Hard work. Yeah, come up. Whatever. Somebody hungry and strong, I need. Go ahead. Come on. There you go. What's your name, sir? Kyle. Thanks for volunteering, Kyle. I will give you a donut here. Let's see. Okay? Don't eat the paper. Okay? 1 second. 1 second. Don't laugh at Kyle. No, not eating it. No eating it. No eating it. Okay. So here we have a dynamo. Okay? And so you have to crank the dynamo. If you crank it hard enough, it's about 100 watts. It's actually less, but let's say that the bulb is 100 watts. Okay? So now you're putting in all this food. You're going to work it off here by cranking this dynamo. Are you right-handed? Can you turn to the right? Yeah. Not like this, but this here. Yeah, okay. So you got to crank this and eat while I'm asking them a question. Your eye clicker is there, and your neighbor will click for you in the eye clicker. Okay? That you get the extra points. So please go ahead, sir. Don't give up. Okay? And so the question I'm having here now. Let's go put this up here. Keep going. Eating. For what period can a 100 watt dynamo be driven after the consumption of one donut? That's him. That's Kyle, yeah? Kyle. Is it seconds, minutes, or hours? So this is actually a question that you can calculate. Let's see if you can't do that, and try to give me an answer. How are you doing, Kyle? Good? Good. Eat slowly. That energy needs to last for quite a while, actually. He's already done with seconds, but I don't think he... Okay. Yeah, exactly. Yes, give him a hand. Look at that. Kyle, did you push his button? Yeah. What answer did you give? He picked C? Okay, so we're going to be here for a while if you pick C. All right, so think about it. That's not a joke, the whole question. It's real. So you know the calories of one, it's 400, okay? And how many joules is that about, okay? And so you have to keep it at 100 watts. All right, Kyle, how you doing? Eat. It's tough, isn't it? Yeah, exactly. I'm sorry. Easy. No lawsuit, please. Okay? And so, all righty. So let's see what the answer is. Yeah, it's between minutes and hours. I will give you the solution for this. Because you're probably not going to get it anyway. Because oh, I'm sorry. Okay, let's do it again. I will not give you the solution. That was uncalled for. I apologize. You're absolutely right. Yeah. Okay, let's do that again. How can you say something like this? Okay? I apologize. All right? I wanted to help you, but I didn't. I stuck my foot in my mouth. It's all in good sports here, okay? Hopefully. Here comes the lawsuit. It's actually a simple calculation. So let's give you a hand, give you an applause. Thank you very much, Kyle. Okay, thank you. You've been a good sport. I already gave you all the hints, actually, okay? But it's a calculation, you know? It's not a guess. So that's the calories here. First you need to calculate it in joules, okay? And then we have to sustain it at 100 watts. So how many seconds does he need to do that? So let's look at this. Now I'm going to prove it totally wrong. Not totally, but pretty much. Yes, excellent. You're all the best. Okay, now. So you have 400 calories. 400 times 4 is 1600 times 10 to the third, because we have the big C here. That's 1600 times 10 to the 3 joules. We have 1 watt is 1 joule per second. 1600 times 10 to the 3 joules. To get 100 watts, you need this kind of amount of seconds. 1.6 times 10 to the third seconds. 1.6 times 10 to the third seconds. You have 3,600 seconds per hour. That's about 4. Not about. That's exactly 4.4 hours. So Kyle, you would have to pull a lot here, and this is barely 25 volts. You know, at 25 watts. So you probably have to do it for 16 hours or 17 hours to burn off by putting this dynamo. You probably die of exhaustion first. Okay, so that was about 4 hours, and that was the answer. Now let's do another fun experiment, Karen, please. And so we're having a donut. We're not having a whole donut. We're taking a donut hole. Okay, at that donut hole, we're going to do now a consumption in our body, but we do an accelerated consumption because we don't use gaseous oxygen, we use liquid oxygen. So that will make it fast, the whole thing. But it's essentially what happens. If you eat, you breathe in oxygen, you make carbon dioxide and water. And so we have our liquid oxygen. Is this an exothermic reaction, you think? So Karen did the calculation. That's why he's pretty high here. Exothermic means it releases energy. The reaction. So what Karen will do, she will heat up the donut hole a little bit to get it started, so to get the glaze burning a little bit, okay? And then she will insert it into the liquid oxygen, and then watch what happens. Just think of it, you're putting it in your body. And this amount of energy will be released, hopefully, over a longer period of time in your body. I don't know. It depends if your experiment works or not. You need to get it a little bit burning at the surface. You will smell the nice caramelization process. Now pay attention closely to the pot there when she puts it in the pot. Yeah, it might be loud, maybe not loud. Look at that. Look at that energy. That little donut hole. Okay, boom. Look at that. That's what you're putting in your body. That's not even 400. That's maybe 50 calories. Okay, less than that. Okay, there you go. It keeps going and going and going and going, like the Energizer Bunny. Okay, that's us. Keeps us going and going. Can you believe that little donut hole has this much energy? There you go. It keeps going and going and going. What it's making CO2 and water. Okay. All right. Thank you very much, Karen. So now I'm asking you a question towards the end. We have the reaction. There's heat released in the following reaction. This one we just did here. And that makes 6 CO2 and 6 H2O. You can calculate this actually here. And the iron oxide, that's the thermite reaction, releases also a lot of heat, makes iron and aluminum oxide. So I'm asking you, is reaction 1 and reaction 2, is 1 the energy release, the heat release larger in reaction 1? Is it the same than in 2, or is it smaller than in the thermite reaction? Why don't you give it a try and give me your answer? So that's our thermodynamics. 6 times that energy, but this is 0, okay. This here you have here, this here you have, 6 times this here, 6 times this here, you add it together, subtract this is the first thing. You have this here, that's 0, obviously. This here you have, this here you can calculate, you have here, minus, this is 0, minus this here, so you have the difference here. Don't forget the stoichiometric factors. So is the thermite reaction bigger or the glucose reaction? No, you gotta calculate it. Feelings, yeah, okay. Feelings won't help you. But. Okay. So we will talk about this on Friday at the beginning of the lecture. That will give us a nice review then. You have a good Wednesday. Don't float away.